Welcome, everybody, at the Hydrogen Fuel Cells Group exhibit at the Hannovermesse 2022. Please have a seat here at the public forum. I'm very much looking forward to have you here. Grab something to drink, have a seat, enjoy the upcoming talk. I think it's a very relevant topic. My name is Muriel Burkas, and I will do the interview. The next topic is something that I think everybody is concerned about or affected somehow. We will talk about hydrogen-powered aircraft by Apus. And please welcome with me on stage the CEO of Apus, Phillip Scheffel. Thanks for being here. I'm very much looking forward because it's the first time that Apus is here at the Hydrogen Fuel Cells Europe. Before we start the interview, we would like to show a short video what the company actually does. Nice. Welcome, Phillip Scheffel.
Thank you. Thank you for being here.
We just saw in the video what your company is doing. Still, for the broader audience, maybe in a few sentences, what is your company exactly doing? Can you give a short overview?
Apus generally is developing aircrafts or aircraft systems, and we have three business fields. One is generally engineering. The second is developing powertrains, hydrogen powertrains, and the third is developing whole aircrafts, and that's our passion. That's what we want to do for the next years. Two aircrafts, the Apus I2 and the Apus I5. One of this exhibit is on this exhibition. Yeah.
You already mentioned your passion, what you're passionate about. You also told me a bit about your background, so you have a personal connection and passion, I guess, for aircrafts or flying. Maybe can you elaborate a bit on this, how you ended up in this field?
Very much. I have the luck to live and work my passion. I started flying 30 years ago when I was 13 years old, and since this time, I fly gliding competitions and so on. We always treat with energy, with less energy. That's a sport in this case, and train our senses to work with a plenty amount of energy only.
So your experience from gliding helps you nowadays in building aircrafts. Is that right, somehow?
First of all, it motivates me a lot. And secondly, yes, it helps because we have much less efficient powertrains, frankly speaking, compared to fossil energies and fossil powertrains. In aviation, much less energy density, 10 times less power density overall system, and that's what we have to compensate on the aircraft side by better aerodynamic efficiency. And the long years of development of gliders in the past, I was also working in the glider factory before, helps. And it helps also in Germany, because Germany is one of the core manufacturers of gliders and high aerodynamic efficient aircrafts in the world. Yeah.
It's really interesting. I wasn't aware that you can, like, kind of there are the same challenges in the gliding or the gliders, or also now with the new hydrogen aircrafts that are you trying to build, or you are building. It's not just trying. At their booth, you can also see one of the aircrafts, what is really exciting. You decided to build your own aircraft. Why is that? Why not work with what is already here, what is out there, existing aircraft?
Because those new powertrain, we call it all hybrid powertrains, because also fuel cell is a hybrid with the battery. Those hybrid electric powertrains are totally different compared to combustion engines. When we have combustion engines, we have a single point of mass somewhere in the aircraft, and in hybrid powertrains, we have the batteries, we have the converters, we have the high voltage cables, the fuel cell, the electric motors, and everything is distributed in the aircraft. And that doesn't fit with the weight and balance of conventional aircrafts. And the second thing is the storage challenge of hydrogen. We have a volume limitation, and hydrogen needs a lot of volume, so we have to use anyhow the volume in the aircraft and increase the volume without increasing the drag of an aircraft. And conventional aircraft cannot deliver that. So it is maybe a first step, but it will not exceed so much the performance of battery electric flying. Once you want to use hydrogen in aircrafts, it must look different. And that's what you can see on concepts of Airbus nowadays, those big wing, single wing aircrafts, and so on. And that's why we are forced to develop a new aircraft. Is not that we wish it, even it's our passion. It's, yeah.
Okay, let's dig a bit deeper on the aircrafts you're building. So far, there are two types of aircrafts. What is the difference between the two aircrafts?
The difference is the size. The main difference. We have to do the development step by step. We start with a small aircraft where hydrogen just is feasible. When the aircrafts become smaller than 4 seats, the battery electric powertrain has advantage, but on bigger aircrafts, the hydrogen makes more sense. So we start with a 4-seater aircraft. That is what we are exhibiting here, and the next step is the 9 to up to 19-seater. Next step means only technology-wise. Time-wise, it's in parallel. We do that in parallel. So that's the main difference. The small aircraft has 4 seats, the bigger aircraft 19 seats. Yeah.
And why do you stick, for the moment, to smaller aircrafts? And why are there not already like big aircrafts around us? What is the challenge?
Because there's a step in certification standards. Up to 19 seats, we are in the EASA. EASA is the European Safety Agency. We are at the lower certification standard, CS23. And from 19 seats on, we have to prove much higher reliability, and the test and development effort is double or 3 times bigger. So we want to make the technology mature enough in the smaller certification classes. That means smaller investment, and then scale it up to the bigger aircrafts. That's definitely the goal. Yeah.
Okay. We have other interviews about scaling up, so that's going to be a different topic later on. So we have the 2 aircraft, the smaller one up to 4 seats and the other one up to 19 seats. Who are the clients? Who is needing or buying these aircraft?
There are different circles of clients. For the small aircraft is B2C, so private customers. Some people that bought 6 or 7 years ago the Tesla are people that will buy such a fancy technology like the Apus i2. But anyhow, it is already, it makes sense economically wise already to buy such an aircraft. And the other customer circle are fleet operators. It's a commercial application to transport passengers or cargo operators. And yeah.
Okay, so can you elaborate a bit on the countries you're operating? Where is your main target market you're in?
The market starts in Europe because the political pressure is the highest. We don't see this in other countries so far. But anyhow, the mission for the aircraft actually is to bridge low developed ground infrastructure. So when you have only a ferry boat or only a small road or unpaved roads even, then those aircrafts are used for range to 500 kilometers, 500 to 800 kilometers. And this mission profile is needed more on the southern hemisphere, Africa, South America, Asian nations, and that's the second market we are approaching.
You told me about the Asian market, or one example where it's needed when it comes to cargo. What is like maybe also a trend that we saw in the last 2 years concerning online shopping? How is your aircraft a solution in the market?
There's definitely a big need when you look, for example, to Indonesia. They have 7,000 islands, and all those people want to benefit from the consumer market. They want to be delivered 24 hours after they click the purchase. So what we see there is the next ecological disaster, let's say, because the logistic companies have to deliver, they have to provide that service, and we want to be one step in advance here to directly conquer that market with zero-emission aircrafts. There is this need to deliver small amounts of cargo, and this is exactly what can be do with those small aircrafts even today. Yeah?
So this sounds very exciting. Imagine I have enough financial possibilities to buy one aircraft. Would that be possible? And when could I fly with it? Tomorrow, or what is like? What is the time horizon?
Yeah. Unfortunately, today there's no aircraft available with zero-emission powertrains. I exclude sustainable aviation fuels because for me this is only a bridge technology, is not really emission-free. And the first aircrafts on the market we expect in 2025. Our aircraft will fly first time end of 23. And then there will be 2 more years for the final certification tests, and then there's a ramp up, and until 27 we will be fully in the market. We try to develop that with partners such as Rolls-Royce. We are doing this together, the powertrain development together with bigger partners, and the roadmap of the competitors is more or less the same. We are quite advanced because we started development in 2015 already, and that sounds, for normal industry product cycles, it sounds very long, but for aviation it is not. It is when you develop an aircraft with conventional technologies, you have to assume something between 6 and 7 years from the first scratch until certification, and here we have a lot of new technologies in the aircraft, so it is still ambitious. Yeah.
So I still have time to save some money to then be
yes.
one of the pioneers also in this field. Okay, that's exciting. So let's say now I got an aircraft and I'm excited. Where do I get the hydrogen?
On the ground. You have to get it on the ground. And yes, what I saw today, this morning already, to have a short visit to other booths here, I see a strong movement in the developing of ground infrastructure. That's what we need. We are working together with several partners that are also here, and we will use the same infrastructure like automotive industry is using. The truck industry is building up such hydrogen fuel stations. We are using pressurized hydrogen, non-liquid, because of the more simple ground infrastructure. and I'm very optimistic then that up to that in the year 25, 27 there will be enough ground infrastructure to get your hydrogen fuel.
So, if we see how it's growing here, I'm very positive, optimistic that we'll get there. Maybe to the audience, are there any questions from the audience? Everybody's mesmerized by the topic. There is a question.
Then I may take the opportunity to ask, you're probably familiar with the plans from Airbus. How do you look at that? Is that realistic that they plan to fly several thousand kilometers in quite large planes?
I think it's realistic. The step is very big. What they do, they start directly on the very big aircrafts. Of course, they have to use liquid hydrogen to fulfill their missions. But simply, I don't see any other technology. All plans to do battery electric flying in that range, and I would say more than 10 passengers, there's no technical solution so far. Everybody is only hoping on high energy density on batteries, and they hoping really on doubling or even more the energy density, and there's the only way. I clearly see a way to do it. Yeah.
Thank you very much for the question. Another question? Yes.
Yes, hello. My understanding is that you're looking for gaseous hydrogen, for pressurized hydrogen. So are you looking for 350 or 700 bar technology? And how about 700 bar on the aircraft? Is this? Is it,
we are even below 300 bar because the fuel tanks are too heavy when we go to 700 bar, and that suits to. And it is also a contribution to the more simple ground infrastructure, because we can start with simple overflow solutions on the hydrogen fuel stations. So we don't need liquid cooled, we don't need high pressure hydrogen. 350 bar is sufficient. You delivered that?
Let's make business afterwards.
Yes.
This is the perfect ending for today's interview with you. Thank you so much for being here. Have a look at their booth. It's really exciting. You see the aircraft. You see a tank also. It just got here. The booth is at the very end. You just walk down on the right side. You can't miss it because there's an aircraft standing there. So have a look. I think it's very important for all of us in the society. So thank you for being here. Thank you for dedicating your life to this project. I think it's really meaningful, and it's your passion as well, so even better. Thank you so much for being here. A big round of applause for Phillip Scheffel.
Thank you for the invitation very much.